Assalamu alaikum students. I'm Haris Hakim. Today we are going to learn use SI based units to check homogeneity of the physical system. The same SL is also present in ATUEB as well as the same similar SL is present for the CIE levels. Before starting this SLO, we must know what about the SI based units. Okay, so we have 7 base quantities in SI system. Most of you have viewed my previous video, so we will recall it. Just like there are 7 base quantities 1, 2, 3, 4, 5, 6, 7. The first one is length. Means physical quantity is physical quantity. Then the second one is mass. The third one is time. The fourth one, amount of substance. And the fifth one, thermodynamic temperature. Thermodynamic temperature. Luminous intensity and electric current. Luminous intensity and electric current. These are 7 base quantities in the SI system. Question arises why we are going to learn it? Because we are going to check the homogeneity in the physical equation using SI base units. So what are SI base units? These are 7 SI base quantities, their corresponding units or SI base units that we have done in the previous video as well. So length must have SI base unit as meter. We will present it with M in the same way. If we do have mass, it is having the SI base unit as kilogram. And the third one we do have is time. The SI base unit for the time, that is second. Thus we do write S. Amount of substance, we do have mole, but the symbolical presentation we do use MOL. The full name is MOL, just like kilogram, KILO, GRAM. So we do represent it kg, so in the same way MOL, mole will be represented as MOL in short. Thermodynamic temperature, that will be measured in Kelvin. In the same way, luminous intensity, we do have candela, but we do present it with the letter CV. Electric current, we do represent in ampere. That we have recalled our previous video. Okay? Because this thing we are going to use in this lecture as well. So take a screenshot for this because we are going to use it in this SL. Okay. Now we are going to start a little bit how will you convert physical quantity in terms of SI base unit, means from drive unit, how we are going to represent as the base unit. Just take an example for the power. Okay. Power. That is basically rate of doing work. W over T. Work for unit time. Work for unit time. And its drive unit is basically what? It's derived unit. This one derived unit. Because this does not belong to the base unit, so it will be the derived unit. So this is derived unit. Now question arises how will you convert it to SI base unit? So that is much easy. What we will do, we must know the unit of work. From the unit we can also derive, from the formula we can also derive. So work is basically F dot T and time ST. Now question arises, force having the derived unit as Newton. Force is being measured in Newton. A push or pull is called force. Okay, so Newton will be Newton having the symbol capital N, and then displacement is meter. Meter is already a base unit, while the force is a derived unit as Newton. We can convert it as well. That we have done in previous video as well. Not to worry, we can also do it right here. Time as second. Okay. The question arises, force is equal to MA. How will you convert it? Yes, we have done already in the previous lecture as well. So 1 Newton we can write as mass is measured in kilogram, and kilogram is the base unit. You can see this. Mass is measured in kilogram. So we can write as base unit kilogram. Acceleration. We all know that acceleration having the base unit, that is meter per second square, already base unit. So instead of writing 1 Newton or simply the Newton, we can write kilogram meter per second square. Square, kilogram meter per second square, and this meter we will write right here over second. This second we are writing right here. So power having the base unit, just we are going to simplify it right here. Power will be kilogram meter square per second cube. Kilogram, and why do meter square? This meter and this meter, they are going to multiply. So whenever the same base we have, and they are going to multiply, their powers are going to add. In the same way, second square into second, that will make second cube. So more simply, we can write the base unit for the power as kilogram meter square second minus 3. Okay, so this is the base unit, SI base unit, SI base unit for power. For power. Also, this question was present in exam, CIA levels. They determine base units for the power. So base unit for the power, that is kilogram meter square per second cube. So the second step to do this, in this SLO you can do it after having knowledge of SI base unit, and we must know how you convert the the quantities or the units, derived units to the base units. Okay, just like derived unit of this power, that is watt, and we have converted as kilogram meter square per second cube as a base unit. You can see this kilogram also belong to the base unit, SI base unit. Meter square means meter, also belong to the base unit. In the same way, second cube means second, also belong to the SI base unit. So in this way, this is the second step. Now, if we do have the knowledge of these things, and we have in detail discussed all these things in the second lecture. Okay. Now come to this SLO, how we do attempt it after having this knowledge. And now take the screenshot. Those who need. Dear students, here we have the question related to the SLO, that is use SI base units to check the homogeneity of the physical equation. Basically, to check the homogeneity of the physical equation, either we do put the SI base unit on both sides, we do get the same result, or either we do put the SI base units of remaining physical quantities, and we can determine the rest of the physical quantity. Just like we do have the 4 physical quantity, we can easily determine the 1 physical quantity out of it by replacing other one. We have the question, the speed v of sound wave through a gas of density rho and pressure P is given by the equation v is equal to under root Cp over rho, where C is constant, rho is density, and pressure is representing as P. So we can solve this question, and this question is given in my June paper 2015, paper 2, 3, and question number 1.
Most of the time we do see that these types of questions are going to come as a question number 1. Keep in mind C is a constant right here, and we have to prove that C has no unit. So we can do it easily. The first step is replace the SI base unit. So we can see V is the speed right here, C is the constant that we want to determine, and we want to show that it is unitless. P is pressure and rho is density. So in the first step we are going to replace, we are going to square on both sides so that we can make the subject as C. After making a square on both sides, you can see that the left side becomes V square, and square root Cp over rho we do have. The square is getting cancelled with the square root. Now we need the SI base units of Cp, rho and V. Now speed, we all know that distance covered in unit time. So its SI base unit will be meter over second. Yes, you can see this, meter over second. Now we are going to determine the SI base unit for the rho. Rho has the base unit. We all know that rho means density is mass per unit volume. So mass is being measured in kilogram with SI base unit, and the volume is being measured in meter cube. So its SI base unit will be kilogram per meter cube. No need to convert it, already it is the base unit, SI base unit. Now we are going to move towards P, that is basically pressure. Pressure, we all know that force exerted to unit area. Now force is being measured in Newton, area is being measured in meter square, so its unit will be Newton per meter square. But unfortunately Newton is not being the SI base unit. So what we need to convert this Newton as SI base unit. So Newton is being the unit of force. So force is basically the product of mass and acceleration. So we can represent as the product of mass and acceleration in terms of units. Mass is being measured in kilogram, and acceleration is measured in meter per second square. So Newton we can write as kilogram multiplied by meter per second square. Only Newton we can write this. In the denominator we do have meter square as well. Now we do have two m's which we can solve it by using law of indices. Finally, kilogram meter over second square and kilogram over meter square. We can solve it. Meter power 1 and meter power 2. One of that is numerator and another one is denominator. According to law of indices, if two bases are same with different powers and they are dividing, so their powers are going to be subtracted. So we can write it simply meter power 1 minus 2 over second square, or more simply we can write it s minus 2, because whenever we move the denominator to the numerator, the sign of power will be changed. So kilogram per meter per second square we can write as pressure, SI base unit. Now this is the time to replace the SI base unit of pressure, the SI base unit of density, the SI base unit of speed, as we have done it on the right side. So speed we are replacing as meter per second. There is a square, so we will write square. We will write a bracket and the square here. Rho has unit kilogram per meter cube, and there is no power on it. So we will write kilogram per meter cube only with the bracket sign. Now P we have calculated on the right side as kilogram per meter per second square. Kilogram per meter per second square. Now we will open the square of this meter per second, means it becomes meter square over second square, multiply by kilogram over meter cube, and this third term we can represent as a second term, means 1 over kilogram into meter power minus 1 and second power minus 2, and then further kilogram is getting cancelled with kilogram, and this minus 1, m minus 1, we are going to shift on the numerator. It becomes m power 2 plus 1, and minus 3, or more simply 2 minus 3 plus 1. And in the denominator we do have second power 2 and second power minus 2. We all know the law of indices. If we have the same bases and they are multiplying, their power are going to add. S power 2 minus 2. So again we all know that 2 minus 3 is minus 1, minus 1 plus 1, that makes 0. Power is being 0, m power 0, and similarly s power 0 we do have 2 minus 2. So whenever we do have a constant with power 0, it will becomes 1. So 1 over 1 is basically 1, but it does not have any unit. So it is being proved that there is no SI base unit for the C. So it is being unitless. It is being proved. Take the screen. You can take the screenshot.
Okay, again the second question we do have, that belongs to the same SLO. Use SI base unit to check homogeneity of physical equation. A mass m is placed on the end of a spring that is hanging vertically as shown. You can see this. This is the mass that is being attached to the spring, which is hanging vertically right here. The mass is made to oscillate, means we have stretch it once and then it causes to oscillate right here, up and down, to and fro motion, that is showing right here. The time period of the oscillation of the mass is t, means t is representing the time period right here, this one in the formula. The time period is given by t is equal to c times square root m over k. What is m? M is the mass of the spring. M is the mass that is attached to the spring, that is hanging vertically, while k is the spring constant. K is the spring constant, and again we have to show in this second question as well, show that c has no units. And this is the question given on the year October, November. Its code is October, November 2014, and paper 2-1, paper 2-1.
and this is being the question number 1. Most of the time they will give this SLO as question number 1. So the second example in CIE levels, you can see right here, October November 2014, paper 21, paper 21, and question number 1. So again we do solve it in the same way. We have the question as T is equal to C times square root m over k, and m is being the mass of the oscillating body that is attached to the spring vertically hanging, and k is the spring constant. C we have to prove as unitless, and t is being the time period. So we all know that t has the SI base unit as seconds, and if we do talk about mass, having the SI base unit as kilogram. In the same way, K is being the spring constant. K is spring constant. Spring constant. Okay. So spring constant is basically the ratio of force over extension. Force over extension. Force over extension. That is being derived from the Hooke's law, F is equal to kx. Basically we are writing this from the Hooke's law, F is equal to kx, x is being the extension, F is being the force. So we all know that force is being measured in Newton, and extension means a kind of length, increase in length. So that extension we do represent in meter. So meter is already in the base unit, so we have to represent this Newton as the base unit or SI base unit. So we can write it kilogram meter over second square, as we have done in previous case as well. So over meter we do have. So finally we can write as kilogram meter over another meter into second square. So these 2 meters are being cancelled out. Okay, so finally kilogram over second square. Okay, so in the same way we are going to put their units right here. So time as, again we have to separate in the first step as C. To separate C, what we will do, we will first make it square, squaring on both sides, squaring on both sides. Okay. Now replace T as second, SI base unit, now squaring on both sides. So this becomes T as T square, and C becomes C square, and this M square root over K, this becomes cancelled out with the square sign. So T square and this M times C square over K, and we have to shift this C square as separate. C square will be K times T square over M. Replace it. K is being the spring constant, we can write as kilogram over second square. So kilogram over second square. T is being the time period, and we have to represent it with second right here. So replace it as second, but we do have a square. Okay, over M is being the mass, that is kilogram. We have written right here. So M, don't confuse with M. If it is written as SI base unit, so it will be meter, means the unit for the length, and only M written in the formula means representing the physical quantity, so M is mass. So don't confuse about that. Okay, and second square also being cancelled out with the second square. So C square is unitless, and if we do take its square root, taking square root because we need to prove it that C is unitless, taking square root on both sides, yes. So C square root, and we do have unitless means no unit. Unitless means no unit. So no unit, we have proved it. Take the screenshot of this whole to understand it better. Now we will move to the third question. Okay, let me have the third question related to the same SLO SI base unit to check homogeneity of the physical equation. The potential energy EP is stored in a stretched wire is given by, means we do have a stretched wire, means wire that is being stretched, that is being, where EP is the stored energy that is being represented right here. C is the constant and sigma is a strain. V is the volume, you can see right here, this V is the volume, sigma is the strain, C is a constant. Now this time in this third question, we have to basically determine the SI base unit of the C. Now this, in the third question, we don't have to prove the C is unitless. So how we will do it? That is much easy. Keep in mind, we have strain as sigma. So sigma, we all know that, of the strain, we all know that a relative change of deformation means the sigma is strain. Strain means if we do have the volumetric strain, so it is delta V over V, or if it is the tensile strain, means delta L over L, and if it is so what you have to do, so this will have the same unit, means meter cube, the change in volume, and meter cube. So it is being unitless, any kind of strain we do have. In the same way, change in length over length, change in length is also measured in meter, and the length or original length, that is also measured in meter. So this is also unitless. And if it is shear strain, means delta A over A, delta A over A. Delta A change in area, that is also measured in meter square, over A, that is also meter square, that will be cancelled out again. Unitless means whenever we do have the strain, that is unitless, no unit we can use it. So we will write unitless means no unit. So it's a square becomes a square also unitless. So just we have to put the unit of volume, and we have to determine the unit of C, and EP is the energy. So what about E? Energy, the capacity to do work. Okay, so energy and work having the same unit, energy and work, the capacity to do work is called energy. So that is being measured in joules. Joule is no more a base unit, so we will transform. Energy is the capacity to do work and its unit is joule. So joule is basically drive unit. We can write the unit of work as well, Newton meter as earlier, F into D. But again, meter is the base unit while Newton is the drive unit, so we can transform it. So Newton, as we have converted earlier, kilogram meter over second square. Kilogram is being the unit of mass, and meter per second square will be the unit of acceleration. Multiply by meter, we do have this one. So energy we can write as kilogram meter square, and second minus 2 we can write it. We have shifted this denominator into the numerator. After that, sigma we have done unitless, energy EP we have done it, energy EP. Okay, this EP is representing energy. Now V is being the volume. V is basically volume. Volume is basically measured in meter cube. We are talking about the unit, SI base unit. Already we do have, that is meter cube. Now replace it in the given question, that is EP is equal to half is unitless. So in case of homogeneity of the physical equation, number does not take a part because we are only dealing with units for the homogeneity. So half C sigma square V. So EP we are going to write as kilogram meter square per second square. So EP we are writing kilogram meter square per second square, S minus 2. Half is unitless, okay, so no need to write it. So C, move towards C. C we need to determine SI base unit of C, so it will be on the right side. Sigma is also unitless, so no need to write unitless. Sigma is unitless, that we have proved. Either it is volumetric strain, either it is tensile strain, either it is shear strain. So unitless. So we will move towards, because we are only dealing with units, okay, volume meter cube. This meter cube is multiplying, we will shift it on the left side. Yes, you can ask that in the previous case we have first make the subject as C and then we have solved, and right now we doesn't make the subject C earlier. First we will put the unit. So there's no hard and fast rule. You can even make a subject first and then shift it, or you can first put the unit and then make the subject, and finally you have to make it this subject because you have to find out the unit of C. So meter cube is multiplying, it will divide kilogram meter square over meter cube per second square C. Now finally it comes out to be kilogram. There is a base which is dividing, so meter power 2 minus 3 second minus 2, this will be the unit. Now more simply we can write as kilogram meter power minus 1 second power minus 2. So this will be the unit for the constant C. So this is the third question. Take the screenshot to understand it. And this was the question for CIE A levels, and its code is May-June 2014, paper 2-3. This was the question 1. Again and again I am repeating that they will give a question number 1 belonging to this SFO. Okay, the fourth question related to this, that is May-June 2013, paper 2-1, question number 1. So question number 1 they will give it most of the time regarding this SLO. So for the wire extended elastically, means a wire is being stretched, the elastic energy per unit volume X is given by, means energy per unit volume, means elastic energy per unit volume is X, while C is a constant and this epsilon sign is strain, and this E that is Young's modulus. Keep in mind E is Young's modulus. Previously they have given a question in which EP was the potential energy, but right now E is no more energy, E is Young modulus of the wire. So show that C has no unit. So what we will do, we have to determine that C have no unit. So what we will do, first we will find out the unit for X, and then we will determine the unit for E or epsilon, and next step we will find out the unit of capital E. So what we will do, this X is basically energy stored per unit volume, energy over volume, energy over volume. Energy we already know, that is Newton meter. The capacity to do work is called energy. So first we can write for the joules, and then we can write Newton meter over volume is being measured as meter cube. So these two meters we can separately solve easily. So Newton over meter square means 1 power will be subtracted right here. Then Newton we have to transform, that we can write as kilogram meter over second square, and this 1 over meter square we can write separately as a product. Meter power 1 we can write in this way after cancelling out or after subtracting the powers. So it turns out to be kilogram over meter square second square in the denominator. In the same way, the best way to write kilogram meter power minus 2 second power minus 2. So energy, X is basically elastic energy per unit volume. So energy has the base unit Newton meter, and the energy having the drive unit Newton meter, we can transform it easily, while the volume having the base unit as meter cube. So we can transform this Newton meter is being cancelled out, so only square left right here. Newton we can represent as kilogram meter per second square, and 1 over meter square we do have. The powers are being subtracted right here. So finally energy stored per unit volume, that comes out to be kilogram per meter per second square right here. Now come to this epsilon. Epsilon is strain. Epsilon is strain. Strain is unitless, already we have discussed. And capital E is elastic modulus or Young's modulus. Young's modulus, that is basically the ratio of stress over strain. Stress over strain, stress is basically F over A, or internal resistive force exerted to unit area. Strain is again unitless, so Newton per meter square, that will be the unit for the stress, means F over A, while this is being unitless, no unit or unitless. So we can only focus this Newton per meter square because we are dealing with base units. Just convert this Newton. So Newton we can write as kilogram meter over second square, and 1 over m square means 1 over meter square we can write right here. Now elastic modulus or Young's modulus we can write as kilogram. Meter power will be subtracted, so it becomes meter power minus 1 second power 2. So kilogram over meter power 1 in the denominator, and we can shift it in the numerator to have the minus 1 power. So we can write as kilogram meter power minus 1, meter power minus 1, and second power minus 2. Now replace it in the given formula. X we have did, C we have to prove, means we have to determine, E we have given as Young's modulus kilogram per meter per second square. So now replace it right here. First make the subject as C. So X over epsilon square and capital E. X we can write, because energy per unit volume, that we have calculated, kilogram per meter per second square. Kilogram per meter per second square over epsilon means strain, that is unitless. No need to write with its square, because no unit with the square, we don't have any unit, no unit. So we can write it only E, means Young's modulus, that is kilogram per meter per second square. You can see this C will comes out to be without any unit. Why? Because kilogram is getting cancelled with kilogram, meter is being cancelled out right here, just like this, minus 1 and plus 1, and second minus 2 plus 2 comes out to be no unit, no unit. So this has been proved. Kindly subscribe my channel and share it and comment it. Thank you.